Thank you, everybody, for joining this session. So we hope you and your loved ones are staying safe from the ongoing pandemic, and we're just glad that you could make it to this session. I'm Sumant Venkatesubaya, and I have with me Pankaj here, my colleague. So we are both part of the AI services group at Intuit. So where we are focused on building capabilities to help in the variety of stages of model development lifecycle. Our team is also involved in building general purpose scalable AI services to help accelerate the adoption of AI across the company, across the variety of products and services within the company. All right, so here's the agenda. So we plan to cover quite a few things. So we have structured the talk to begin to give you some high-level context, and then we'll get into the details of the internals of the system. So we'll just be sharing our experience in building the variety of capabilities, which will help in a variety of model development lifecycle stages. So we don't want to be prescriptive. It's just our take on how to solve some of the challenges that we have encountered at Intuit. So about Intuit. So for some of you who may not know what Intuit does or who we are. So we are the company developing some of the financial software, which are most widely used both within the US and outside the US. For example, so we have within our portfolio of products, we have TurboTax, QuickBooks, Mint, Credit Karma. So TurboTax is the most widely used tax preparation software within the US. QuickBooks is the accounting software geared mainly towards small and medium-sized businesses, accountants, and individuals. And we also have Mint and Credit Karma, which both serve the personal finance management aspects of your lives. So our mission is to power prosperity around the world. And the way we have decided to do this is with the help of an AI-driven expert platform. And we'll be touching upon some aspects of this, our journey so far in the next few minutes in the session. All right, so I'll go over some of the ML-driven, machine learning-driven experiences within some of our products. For example, in TurboTax, so which is the tax preparation software. So we have a variety of personas, users with variety of backgrounds using this software, and each of their experience using the product is unique to themselves. Right, so we do a lot of personalization behind the scenes. For example, so we use a variety of NLP-based models to provide contextual help for some of the questions that our users might have. So in QuickBooks, so there's some statistic which goes by. So within the US, 20% of the small businesses, they fail within the first 1 year. 30% of them fail within the first 2 years of their beginning. And up to 50% of the businesses fail within the first 5 years, right? And one of the reasons why they fail, most of these small businesses fail, is because they don't have much clarity into some of the future cash flow forecasting for their businesses. So we use a variety of techniques, ML-driven techniques, to help them uncover, help them understand some of the, to forecast some of the cash flows, so that they are successful within their businesses. So in Mint, Mint can categorize a variety of transactions from the accounts that are linked to Mint. So now these transactions are automatically categorized based on like the type of the business, for example, be it restaurant or an airline or a movie show. So Mint has, so we have a variety of ML techniques which enable us to automatically categorize some of these transactions. At Intuit, so we want to power prosperity around the world with the help of AI-driven expert platform. And so this platform-centric approach is helping us solve many of the common problems that we encounter each and every day. For example, so we have built a document understanding platform which allows our users to literally take a picture of some of the receipts or forms and then just upload to an app, and this platform helps, like it can parse the forms, it can literally understand what's in the receipt or the form, and then put it back in the application. So, and we could generalize this, we could reuse some of the capabilities built here within some of the other product offerings. So we have an ML platform, so which is built mainly on top of Amazon Web Services by leveraging a variety of native managed services. Plus, we also have built a lot of abstraction on top of AWS services, which primarily power the whole ML ecosystem within the company. So we have close to 400 plus models, production, which are deployed in production with 25 plus trainings, which are run on a daily basis. We have built a feature store, which houses machine learning features. We have close to 8,000 features there with 15 billion, close to 15 billion updates every single day. And we use a variety of services like SageMaker, Kubernetes. We also use some of the non-AWS services like Arco workflows, which is built by Intuit and open sourced. And we leverage Spark and Beam for some of the data processing aspects of this journey. So the ML platform provides capabilities to train and deploy models. However, what we realized over a period of time was, so there is a need to track the various stages of model development lifecycle. And these, some of the lifecycle stages are like exploration or data transformations, a variety of like the experiments that are run as part of training, monitoring the predictive performance of the model once it's deployed to production. So, and all these things have to be done in a consistent way. And there are challenges in building a central system. For example, so even though we have an ML platform, so not 100% of the models are leveraging this platform due to a variety of historical reasons. So now for us to be able to track across all these models which are in production, so there are a lot of challenges. As you can see, there are a lot of standards which are specific to each teams. There is a lot of variations in how each team accesses data. For example, data is residing in, can reside in S3, or it can be in a database. It can be in a variety of formats like JSON, Parquet. It can be in like the training environments can be different. And there are just numerous model development deployment environments as well. Although we are trying to converge into a single platform, we are not there yet, which really makes it really challenging to build a central system. And why do we need a central system? Because so we need a consistency in the way how we track how we collect some of the metadata. So there's no if there is no consistency, and if it does the manual collection of metadata, it doesn't scale, and it's not updated by model owners. So how often would you want to interrupt your workflows to just come and update some of the metadata on a regular basis? Yeah, our model owners doesn't like it. So there has to be an automated way to achieve this. So as such, we started to think how we can address some of these challenges. At the same time, so we want our customers to have complete confidence in their product experiences. For example, so let's say there's a transaction which is in Mint. This transaction is at a restaurant, but if Mint, for whatever reason, if it categorizes this as an airline transaction, then our customers will lose confidence in the system, right? For example, at the same time, so for our customers to have these confidence in our systems, so we have to build capabilities which will let our data scientists, our model owners, to have complete visibility into a variety of stages as part of the model development lifecycle. Also, there are a variety of stakeholders in this space. For example, execs wants to know different things, data scientists, analysts, so a lot of just to provide observability and visibility into all these stages. Uh, so as we set out to build a system, so these were some of the goals. And I hope you've got some context. And Pankaj, my colleague, will explain our approach in solving these challenges in the next few minutes in the session. Thank you.
Thank you, Sumant, for taking us through Intuit's journey towards becoming AI-driven expert platform company. Hello, guys. I am Pankaj Rastogi. I work as staff engineer at Intuit. Let's continue our discussion on AI monitoring and management. Why do we need it? Who is asking for it? What is the customer benefit? The last thing that you want to build in your company is a system that nobody wants to use. So the answer to these questions depend on your role in the organization. So let's say you are a financial analyst in budgeting group. So your goal is to plan for next quarter and next year. So you need to know how much it costs to train a model, how much it costs to host a model. That way you can effectively plan for the next quarter or year. If you are from operations team, you want to know the CPU utilization, the instance type used for training these model or hosting these models. That way you may want to buy reserved instances for these instances if they are in cloud. If you are a compliance officer, you want to make sure that your models are explainable. You don't want to deploy black box in the production where you cannot explain the inference. If you are a consumer of these models, you want to know the uptime. Let's say you have a model in prod which does not have 4 nines as uptime. You don't want to use that model in your real-time scenario. Or you want to know the latency of the model. If the prediction from a model comes within few milliseconds, then you may want to use it in real-time scenario. But if the prediction takes few minutes, then you can use it in batch mode. Executives in the org are looking for answers like how many models are in production, how many models are in pre-prod, who is consuming these models, number of calls to these models. Machine learning engineers and data scientists are always looking to uh, tune their models. They are looking at various training runs to see how their training runs compare, which one to deploy to prod. So as you can see, there are so many personas in a company, and they're all looking for different answers. So there are multiple solutions. Either you can build different solutions that address their concerns, or you solve it for all in a single system. So at Intuit, we are trying to solve this problem holistically, and that's the reason we are building AI monitoring and management. You can think of the system as consisting of three primary modules: track, monitor, and manage. In the track module, what we have done is we have built a Python package using MLflow open source framework. So it gives our customers the capability to push data into central tracking server. So we have provided APIs that are very similar to MLflow APIs, where you can push hyper parameters, you can push model artifacts like your config file, your training file, your model file, or other metrics that you want to collect during different stages. So you can think of this module as a push-based approach where the customer is responsible for pushing data to the central tracking server. Second module is monitor module. This module consists of various monitoring services like model monitoring service, where we monitor the input features to the model and the predictions from the model. It also has webhook event handler that are listening to events like get commit, get merge. And then we have schedulers that go to data lake and pull the information that we are interested in. So now what do we do with the information that we have collected in our central database? And that's where the third module, manage, comes into picture. So this module provides various insights to the customer and let them take meaningful action. One example would be that the monitoring service detects model decay or data drift, and this helps the model owner to take a decision whether to retrain a model or not. And he or she can take that decision in the manage module. So we want to track the model throughout its life cycle. What it means is that we have to build a lot of integrations. So in the early stages, when you are doing data exploration, you have to evaluate different data sources. You are looking for statistical significance of different features. You are discarding features at this time. So you want to keep track of all these decisions. A few months later, when somebody asks you, why did you pick a certain feature or why you did not pick a certain feature, you should be able to go back to that decision and know the reasons for taking a certain decision. Later on, when you move to experiment stage, where you are experimenting with different ML frameworks or different algorithms, you want to keep track of all these experiments, and you will be doing testing and training later on, where you will be tuning your model. You want to compare these models, so you need to make sure that you have captured all this information in the central tracking server. And then once the model is in prod, you want to make sure that you are monitoring the operational metrics like your uptime, your SLA, and at some point you will start to monitor the features to the model and prediction from the feature. So as you can see, that our clients, they use tracking module to push data to the central tracking server, and all the monitoring services, they also use the same Python package to push data to the central tracking server. So there is only a single way to push data to this database. And how do we retrieve data is through REST APIs. In our manage module, we have built our own dashboards, which provide interesting insights to the users. But then clients are open to use the same REST APIs to build their own dashboards. So let's go a little deeper into these modules. The first one is model monitoring service. So let's say you have a model deployed in prod, which provides inference in less than few milliseconds, and it is up 24/7. And one of the features that it uses is income field, and the upstream system sends you income as bi-weekly income. So you train this model on this feature and deploy it in prod. It's running perfectly fine, providing inference in few milliseconds. Now, one fine day, the upstream system start to send this feature as monthly income. So your model will still provide inference. It will still be up 24/7. Would you call this model as a healthy model? Uh, no, because the inference will be all wrong because one of the input to the model has changed dramatically. And that's the motivation for building this service. What it does is it computes various metrics on the input features and the prediction, like your min, max, count distinct, median, which help us detect such changes. So this service is mostly config driven, where our customers have to provide two config files, and it has two pipelines. The first pipeline is data pipeline, which reads the first config file, and it reads the data sources to go to read the input data. And the second pipeline is the metrics pipeline, which computes all the metrics that I just mentioned. And it is the output is integrated with our own anomaly detection service. So if we detect any anomaly in any of the metrics, we alert the user, and the user can now take some action. In the tracking module, as I said, we have used MLflow. So if you see, the APIs are very similar to what MLflow offers, but we have made certain modifications to the API to meet our own needs. And some of them are listed here. Like we have made this service auto-discoverable. That way, any team within Intuit can use it. We have added authentication and authorization to all the APIs that we offer using our own gateway server. And then the third API, the log artifact API in MLflow, it assumes that the client has the ability to write to the S3 bucket. So we have added I am assume role capability to our client code. That way, this permission issue is handled automatically. And there are some changes that we are working on in this package, which is how do you package this client and server code. If you look at ML flow, the both server side and the client code, they are packaged together, which makes it very heavy. I think it's around 250 MB. So we are looking at ways where we can make it a thin client. That way it is easy for our customers to use. And we have also expanded the schema of ML flow. As I said, that we want to track the model throughout its life cycle. So we want to capture model metadata. If somebody is consuming this model, we want to capture the customer information, like who is using this model. And if there are multiple versions of the same model deployed in prod, we want to get metadata about these versions as well. And we want to capture if the model has gone through different review process. So that's why we wanted to expand the schema so that we can capture all this additional information. And third module, the manage module, it is mostly work in progress, where we present insights to the customer through various dashboards, and we let them take some meaningful actions. And some of the actions are listed here. Let's say you detect model decay or data drift. This will help you retrain or take the decision to retrain your model. And second would be, let's say you have a few training runs done in pre-prod, and you know which model to deploy to prod. So you can pick that particular model and push it to prod. Let's say you have a model running in prod and nobody is consuming it. Do you want to keep running that model? No. So you can decommission that model from this module. Or let's say you have multiple versions deployed in prod and now you want to retire one of the older versions. So these are a few of the use cases that we are working on in our managed module. So as I mentioned that we provide insights to our customer using various dashboards, and all these dashboards are powered by REST APIs. A few of them are mentioned here, like we can give you a dashboard which gives a number of models by model type. So let's say you are a data scientist and you are planning to build multi-class classification model. You can come to this dashboard, you can double click on it, you find all the model owners of these models, and you can find out what features they have used. You can find out their training runs, the hyperparameters. Maybe you can partner with them. Maybe you can see that the problem that you're working on is already solved by some other team. So that is the reason of building these dashboards, that it will help us speed up the development life cycle. And some of the changes that we plan to work in future are adding ethical AI. So let's say you have a model in prod and the feature that it uses is income, but in your training data, you do not have equal representation from all the income groups. Let's say you are missing out on low income group data. So when you train this model, it will not provide a right inference for this group belonging to low income group. So that's what we want to address. And we want to make our models explainable. That means we capture the feature importance for each prediction. And if there is any personally identifiable information used for any of the model inference, we want to make sure that we have done proper risk assessment. So these are few of the things that we are going to work in the future. If any of the work that we mentioned today excites you, please join us. We are hiring. And if you have any questions, do let us know. Thank you so much for joining today. Thanks.